Round 1. Why did Nintendo initially choose NVIDIA for the original Switch? Bucking the trend. You're absolutely right that Nintendo's decision to go with NVIDIA for the original Switch in 2017 was a departure from the industry trend at the time. Let's explore why they made this choice. Even before backwards compatibility with the Switch 2 became a factor industry context in 2017, AMD's dominance. By 2017, AMD had already solidified its position as the go-to GPU provider for major consoles. The PlayStation 4, 2013, and Xbox One, 2013 both used AMD APUs with Jaguar CPUs and GCN. Graphics Core Next, GPUs. This trend continued with the PS5 and Xbox Series XS in 2020, which used AMD's RDNA 2 GPUs. NVIDIA's position. NVIDIA had largely exited the console space by the mid-2010s, focusing on PC gaming GPUs, for example, GTX 900 series, later RTX 20 series, and mobile chips like the Tegra line. NVIDIA's last major console involvement before the Switch was the original PlayStation 3, where it provided the RSX Reality Synthesizer GPU, 2006, but Sony switched to AMD for the PS4. Nintendo's unique needs for the Switch. The Switch, launched in March 2017, was a hybrid console playable both as a handheld and docked TV. This design required a chip that could balance performance, power efficiency, and heat management in a portable form factor. Here's why NVIDIA's Tegra X1 was the right fit. Power efficiency and ARM architecture. The Tegra X1, as detailed in the Nintendo Switch, Wikipedia web result, uses an ARM-based architecture, 4 Cortex-A57 and 4 Cortex-A53 CPU cores, paired with a Maxwell GPU, 256 CUDA cores. ARM chips are known for their power efficiency, making them ideal for mobile devices like the Switch. AMD's offerings in 2017 were primarily x86-based APUs, optimized for higher power budgets. For example, PS4's 1.84 TFLOPS GPU at 30W. While AMD had mobile APUs, they weren't as well suited for a hybrid console needing long battery life and low heat output. The chips and cheese article notes, Tegra X1's low IPU clock could be unique to the Nintendo Switch. NVIDIA's datasheet states the GPU should be capable of 1024 FP16 GFLOPS at reasonable temperatures. Nintendo deliberately downclocked the GPU, 393 GFLOPS in TV mode, 236 GFLOPS handheld, to prioritize battery life and thermal management. Hybrid design innovation. The Switch's hybrid concept was a gamble. Nothing like it had been done before at this scale. The Wikipedia entry mentions Nintendo's challenge. Nintendo needed to balance the power and speed of the console's central processing unit with battery life and the unit size. NVIDIA's Tegra X1, designed for mobile devices. For example, the NVIDIA Shield TV, offered the right balance. NVIDIA had experience adapting its GPU architectures, like Maxwell, for low power use. As the chips and cheese article highlights, Maxwell was designed for discrete GPUs with much higher power budgets, but NVIDIA did a good job fitting it into a smaller power envelope. Cost and simplicity. Nintendo has always prioritized cost-effective hardware to keep console prices accessible. The Tegra X1 was an off-the-shelf chip, already used in the NVIDIA Shield TV, 2015, which reduced development costs compared to designing a fully custom SoC with AMD. The Wikipedia entry notes, one choice made by the development team was to use an existing system on a chip, SoC, rather than creating their own as they had done on previous consoles. This pragmatic approach favored NVIDIA's ready-made solution. Why not AMD? In 2017, AMD's focus. AMD was heavily invested in x86 APUs for Sony and Microsoft, which weren't ideal for a low-power hybrid device, while AMD later developed the Sephiroth APU for the Steam Deck, 2022, using RDNA 2 and Zen 2. This level of optimization for handhelds wasn't as mature in 2015 to 2016 when Nintendo was finalizing the Switch's hardware. Risk of competition. The Wikipedia entry mentions Nintendo's secrecy around the NX, Switch's codename. Miyamoto stated that the company had concerns that competitors could copy ideas from the NX if they revealed it too soon. Choosing NVIDIA, a company not currently in the console space, might have helped Nintendo keep its hybrid concept under wraps, as AMD was deeply tied to Sony and Microsoft. Bucking the trend, Nintendo's decision to go with NVIDIA was a bold move that paid off. The Switch sold over 140 million units by 2025, becoming one of the best-selling consoles ever. They bucked the trend because their focus was on innovation, the hybrid design, rather than raw power, and NVIDIA's Tegra X1 aligned perfectly with that vision. While AMD dominated with high-performance consoles, Nintendo carved out a unique niche, proving that gameplay and accessibility trumped graphical fidelity for their audience. 2. Did Nintendo have a history of partnering with NVIDIA? What about the GameCube and ATI? AMD? You mentioned that Nintendo doesn't have a history of partnering with NVIDIA and suggested that older systems like the GameCube used AMD, then called ATI. Let's clarify this. Nintendo and NVIDIA. Historical context. Pre-Switch collaboration. Nintendo and NVIDIA didn't have a deep partnership before the Switch, but there was some history. The Tegra 3 chip powered the Nintendo 3DS, 2011. Though this was a minor collaboration compared to the Switch, the 3DS primarily used a custom DMP Tiger 200 GPU for graphics, with the Tegra 3 handling secondary tasks. NVIDIA pitched the Tegra 4 for other Nintendo projects in the early 2010s, but these didn't materialize until the Switch. Switch partnership, 2017. The Switch marked the first major console collaboration between Nintendo and NVIDIA. The Wikipedia entry notes, the NVIDIA partnership didn't kick in until early 2015, as per a Reddit thread. Our Nintendo Switch, 2016. This suggests that while there was some prior contact, the Switch was the start of a significant relationship. GameCube GPU, not AMD ATI, but ARX, later acquired by ATI. You're correct that the GameCube's GPU has ties to ATI, but it's a bit more nuanced. GameCube GPU manufacturer, the Nintendo GameCube, 2001, used a GPU called Flipper, designed by a company named ARX. The GameCube technical specifications. Wikipedia web result provides context, though it doesn't directly name the GPU manufacturer. However, historical records confirm ARX's role. ARX was a small company founded by XSGI engineers in 1997, specializing in graphics chips. They were contracted by Nintendo to design the Flipper GPU for the GameCube in the late 1990s. ATI acquisition. In 2000, before the GameCube launched, ATI acquired ARX for $400 million to bolster its graphics expertise. At the time, ATI was a major player in PC graphics. For example, Radeon GPUs. After the acquisition, the ARX team became part of ATI's engineering group, but the Flipper GPU was already designed by ARX before the buyout. Flipper specs. The Flipper GPU was a custom design with a fixed function pipeline, no programmable shaders, as it predated that era. It ran at 162 MHz and delivered around 9.4 GFLOPS, with features like hardware transform and lighting, TML, texture mapping, and a 1 TSRAM memory subsystem for low latency. Nintendo's broader history with GPU partners. Nintendo 64, 1996, used a custom SGI, silicon graphics, GPU called the Reality Coprocessor, RCP, reflecting Nintendo's partnership with SGI at the time. Wii, 2006, used a GPU called Hollywood, also designed by ATI post-Arc's acquisition. ATI had become a key partner for Nintendo by this point. Wii U, 2012, used a GPU called Latte, again designed by ATI AMD. ATI was acquired by AMD in 2006. The Latte GPU was based on AMD's Radeon HD series, with GCN-like features. Summary, Nintendo did have a history of working with ATI, later AMD, for the GameCube, by ARCs, Wii, and Wii U. The Switch's use of NVIDIA in 2017 was a break from this trend, driven by the unique needs of the hybrid design. Correcting the misconception, the GameCube's GPU was designed by ARCs, not directly by ATI, though ATI acquired ARCs before the console launched. Nintendo did have a history of partnering with ATI AMD for several consoles, making the Switch's NVIDIA partnership a notable shift. 3. Personal philosophy on DLSS, modern graphics, and community sentiment. You've expressed a personal dislike for DLSS and modern graphics technologies like RTX, describing the AI upscaling as an uncanny valley experience that doesn't excite you the way video game graphics have since the 1980s. You also note that this sentiment isn't just personal. There are memes and community discussions criticizing DLSS, RTX, and other newfangled acronyms. Let's explore this perspective and the broader reception of these technologies. Your philosophy. DLSS and the uncanny valley. What is DLSS? DLSS, deep learning super sampling, is NVIDIA's AI-based upscaling technology. It renders games at a lower resolution, for example, 720p, and uses AI to upscale to a higher resolution, for example, 1440p or 4K, improving performance while maintaining or enhancing visual quality. The Switch 2 uses DLSS super resolution. As noted in the PC Games article Uncanny Valley Effect, the uncanny valley typically refers to something that looks almost real but not quite, creating discomfort. In graphics, this might manifest as artifacts, unnatural sharpness, or a plastic look in upscaled images. For example, DLSS can sometimes introduce ghosting, blurring, or overly smooth textures, especially in early versions DLSS 1.0, 2019. Your experience, you find that DLSS doesn't evoke the same excitement as the graphical leaps of the 1980s to early 2000s, e.g. the transition from 2D sprites, NES, 1983, to 3D polygons, Nintendo 64, 1996, or the introduction of shaders and lighting in the PS2/GameCube era, 2000 to 2001. Those leaps were groundbreaking and immediately noticeable, whereas DLSS often feels like a subtle optimization that can sometimes detract from the intended art style. Community sentiment, memes and criticism of DLSS RTX web result evidence. The r/TAA on Reddit post, published 2025-0124, captures some of this sentiment. Subreddit focused on the over-reliance of blurry temporally based algorithms that are plaguing modern video game graphics, such as TAA, TAAU, TSR, DLSS, FSR, ZES and more. While this subreddit focuses on temporal anti-aliasing, TAA, it also critiques upscaling tech like DLSS, with comments like, "Can't believe this upscaling and ray tracing crap also got to AMD cards." A specific comment mentions NVIDIA's RTX neural face, a technology showcased in the RTX 50 series demos. Its depth still in uncanny valley territory. This aligns with your feeling. AI-driven graphics can sometimes feel off, prioritizing realism over artistic intent. Memes and criticism. There's a well-documented trend of memes poking fun at modern graphics buzzwords. DLSS artifacts. Memes often highlight DLSS artifacts, like ghosting in fast-moving scenes or overly smooth textures. For example, a popular meme format might show a blurry, upscaled character with the caption, "DLSS, looks good to me. RTX overhype." RTX, NVIDIA's ray tracing tech, is another target. While ray tracing enhances lighting, reflections, and shadows, it's often mocked for its performance cost. A common meme might show a game with RTX on, 5 FPS versus RTX off, 60 frames per second. Caption, "Worth it for those puddles." Buzzword fatigue. The gaming community has grown wary of acronyms like DLSS, FSR, TAA, and ZES, feeling they are more marketing than substance. A Reddit comment from the r/TAA thread sums it up. Assuming this isn't fake, that is exactly what happens with interpolated frames with our current technology. Why the nostalgia for older graphics? Historical graphical leaps. 1980s, the NES, 1983, brought vibrant 2D sprites and scrolling backgrounds. For example, Super Mario Bros., a huge leap from Atari's blocky graphics. 1990s, the SNES, 1990, introduced Mode 7 scaling rotation, F0, while the Nintendo 64, 1996, pioneered 3D polygons. Super Mario 64, despite low-res textures. 2000s, the PS2/GameCube Xbox era broad shaders, normal mapping, and dynamic lighting. Resident Evil 4, 2005, making games look more cinematic. These leaps were transformative, often doubling or tripling visual fidelity in ways that felt magical. In contrast, modern tech like DLSS and ray tracing offers incremental improvements, sometimes at the cost of performance or artistic intent. Artistic intent versus realism. Older games leaned heavily on art direction due to hardware limits. Developers used clever tricks. For example, pre-rendered backgrounds in Final Fantasy VII, 1997, to create immersive worlds. Modern games, chasing photorealism, sometimes lose that charm. DLSS and RTX can exacerbate this by prioritizing sharpness or lighting over the intended aesthetic, leading to the uncanny valley you describe. Broader reception of DLSS and RTX. Positive side. Despite the criticism, DLSS is widely praised for its performance benefits, especially in high-resolution gaming. For example, DLSS 3, 2022, can make 4K/120 frames per second viable on an RTX 4090, which would otherwise struggle with ray tracing enabled. The Switch 2's use of DLSS is a practical choice, allowing 1080p handheld or 4K docked visuals on modest hardware. Negative side. The gaming community's frustration, as seen in memes and Reddit threads, stems from performance trade-offs. Ray tracing, RTX, tanks frame rates, especially on mid-range GPUs. DLSS helps, but it's not perfect over reliance on tech. Developers sometimes use DLSS or TAA as a crutch, leading to blurry or artifact-heavy visuals. As the r/TAA thread critiques, loss of artistic control. AI upscaling can alter a game's look in unintended ways, clashing with the art style. For example, pixel art games looking overly smooth. Your philosophy resonates. Your sentiment isn't just personal. It reflects a broader nostalgia for the days when graphical advancements felt revolutionary and aligned with gameplay innovation. Modern tech like DLSS and RTX, while impressive on paper, can feel like a distraction from what made gaming graphics exciting in the first place. Creativity and immersion over raw realism. Final thoughts. Nintendo's initial NVIDIA choice. Nintendo chose NVIDIA for the original Switch in 2017 to meet the unique needs of a hybrid console. Power efficiency, portability, and cost bucking the AMD trend. The Tegra X1's ARM architecture and NVIDIA's mobile expertise made made it the best fit. Even without a deep prior historical partnerships, Nintendo did work with ATI AMD for the GameCube, via ARX, Wii, and Wii U. So the Switch's NVIDIA partnership was a shift, not a continuation. The GameCube Slipper GPU was designed by ARX, acquired by ATI before launch DLSS and modern graphics. Your dislike for DLSS's uncanny valley effect is shared by parts of the gaming community, as seen in memes and Reddit threads criticizing AI upscaling and ray tracing. While these technologies have practical benefits, they can detract from the artistic charm that defined earlier gaming eras.